Greetings, I'm Bitiancila and I will be explaining our class diagram, which represents a smartphone system. This diagram shows the structure of the system including its classes, their relationships, and multiplicity. Let's start with the user class. The user represents the person who interacts with the system. It has attributes such as name and reference to a smartphone. It also contains several methods that simulate real-world actions like turning the phone on or off, connecting the Wi-Fi, sending messages, making calls, listening to music, browsing the internet, taking photos, and checking the phone status. Now, moving on to the smartphone class, which is the core of the system. The smartphone has attributes like brand, model, and is powered on. It also contains important components such as battery, camera, network module, and storage, along with a list of installed applications. The relationship between user and smartphone is an association with a multiplicity of 1-to-1. This means that one user owns exactly one smartphone and each smartphone is assigned to exactly one user. Next, let's look to the internal structure of the smartphone. The smartphone is connected to battery, camera, network module, and storage through composition relationships. Composition means that these components are essential parts of the smartphone and they cannot exist independently without it. For example, if the smartphone is destroyed, these components are also considered gone. The multiplicity here is 1-to-1, meaning each smartphone has exactly one battery, one camera, one network module, and one storage. Now let's discuss the app class, which is labeled as abstract. This means it serves as a blueprint and cannot be instantiated directly. It defines common properties such as name and version, and methods like open and close that all apps must implement. From this abstract class, we have several subclasses including browser app, camera app, messaging app, music player app, phone dialer app. This is an example of inheritance, where all the subclasses inherit attributes and behaviors from the app class, but also define their own specific functionalities. For example, the browser app can browse URL, the camera app can take photos, the messaging app can send and read messages, the music player can play and consume music, the phone dialer app can make and end calls. Now, the relationship between smartphone and app is an association with multiplicity 1-to-0 or many. This means one smartphone can have 0 or many apps installed. This reflects real-life usage where users can install multiple applications on their phones. Additionally, some apps are connected to specific hardware components. The browser app is associated with the network module since it requires internet connectivity to function. The camera app is associated with the camera since it uses the camera hardware to capture photos. These are associations showing that apps depend on their components but do not own them. Let's also look at the battery class, which manage the phone's power level. It has methods to drain, charge, and check if the battery is low. This interacts indirectly with the smartphone, especially when checking power status. The network module class handles connectivity, such as connecting to Wi-Fi or mobile data. It keeps track of whether the device is connected and what type of connection is being used. The storage class manages the phone's memory, allowing files to be saved and checking available space. The camera class represents the hardware used for taking photos, with methods to activate, capture image, and deactivate. All these components work together to simulate how a real smartphone operates. Now, let's summarize the type of relationship used in the diagram. In association, a general relationship like between user and smartphone or smartphone and apps. For composition, is strong relationship where parts belong entirely to a whole like smartphone with battery, camera, network module, and storage. For inheritance, a hierarchy relationship where subclasses like browser app and messaging app inherit from the abstract app class. Lastly, let's talk about multiplicity, which indicates how many instances of a class can be related to another. One-to-one, or one user to one smartphone and one smartphone to each component. 1 to 0 are many. One smartphone can have many apps. In conclusion, this class diagram clearly models a real-world smartphone system by showing how users to interact with devices, how components are structured, and how applications extend functionality through inheritance. That's all for my presentation. Thank you for listening.
Greetings everyone, I am Laylin Asuncion and I will explain the battery class. The purpose of this class is to represent a battery and manage its charge level. It allows us to drain power, charge the battery, and check if the battery level is low. First, we have a private variable called level. This variable stores the current battery percentage from 0 to 100. Next, we have the constructor public battery int level. This is used to initialize the battery with a starting level when an object is created. Then we have the getter method. Get level. This simply returns the current battery level. After that, we have the drain method. Drain int amount. This method reduces the battery level by a given amount. It uses math.max 0 level to amount to make sure the battery does not go below 0%. It also prints the updated battery level. Next is the charge method, charge int amount. This increases the battery level. It uses math.min 100 level plus amount to ensure the battery does not exceed 100%. It also displays the new battery level. Lastly, we have the islow method. Islow, this checks if the battery level is below 20%. If it is, the method returns true, meaning the battery is low. Next, I will explain the camera class. This class is designed to simulate how camera works in a device. It can be activated, used to capture photos, and then deactivated. First, we have two private variables, megapixels. This represents the quality of the camera. Is active. This is a boolean that checks whether the camera is currently on or off. Next is the constructor public camera int megapixels. This initializes the camera with a specific megapixel value, and by default, the camera is set to inactive. Then we have the active method, activate. This method turns the camera on by setting is active to true, and it prints a message confirming that the camera is activated. After that is the capture photo method, capture photo string subject. This method allows the camera to take a picture of a given subject. However, it first checks if the camera is active. If active, it captures the photo and displays the subject and megapixel quality. If not, it shows an error message saying the camera is not active. Lastly, we have the deactivate method. Deactivate, this turns the camera off by setting is active to false and display a message. Next, I will explain my network module class. This class is used to simulate a device's network connection, such as Wi-Fi or mobile data. It allows the device to connect, disconnect, and check its connection status. First, we have two private variables connection type. This stores the type of connection, like Wi-Fi, LTE, or offline. Connected, this is a boolean that indicates whether the device is currently connected or not. Next is the constructor, public network module. This initializes the network module with the default state. The connection type is set to offline. The device is not connected. Then, we have the connect method. Connect string type. This method connects the device to a network. It sets the connection type based on the given type. It changes the connected status to true. It prints a message confirming the connection. After that is the disconnect method. Disconnect. This method disconnects the device from the network. It prints a message indicating disconnection. It resets the connection type to offline. It sets the connected status to false. Lastly, we have two getter methods. Is connected returns true if the device is connected. Get connection type returns the current type of the connection. Lastly, I will explain my storage class. This class is used to simulate the storage system of a device. It manages files and keeps track of how much storage space is used and how much is still available. First, we have two private variables. Total GB. This represents the total storage capacity of the device. Use GB. This tracks how much storage space is currently used. Next is the constructor, public storage in total GB. This initializes the storage within a given total capacity, and the use space is set to 0 at the beginning. Then we have the save file method. Save file string file name in size GB. This method is used to save a file into storage. It first checks if there is enough available space. If there is enough space, it adds the file size to use GB and displays a message showing the file name, size, and updated storage usage. If there is not enough space, it prints a message saying that the file cannot be saved. Lastly, we have the getter method. Get free space. This returns the remaining storage space by subtracting used space from total capacity.
Dangal greetings everyone. My name is Shane Marian Dadulla and today I am going to explain the app, message app, phone dialer app, music player app, browser app, and camera app classes, focusing especially on the constructor and how the class works. But first, the app class. We have the line abstract class app. This defines an abstract class named app. An abstract class is like a blueprint. It cannot be initiated directly. Instead, it is meant to be extended by the other classes that will provide specific implementations. Next, we see the variables, protected string name, protected string version. These are the instance variables. The keyword protected means they can be accessed within the same package and by subclasses. Name represents the name of the application. Version represents the version of the application. Now let's focus on the constructor, which is the main part. Public app string name string version. This that name is equal to name. This that version is equal to version. This is the constructor of the app class. A constructor is a special method that is automatically called when the object is created. Here is what happens step by step. The constructor accepts the two parameters, the name and the version. This that name is equal to name, assign the value of the parameter name to the instance variable name. This that version is equal to version, assigns the value of the parameter version to the instance variable version. The keyword is to use the refer to the current object, helping distinguish between the instance variables and the parameter that have the same names. Next, we have the public string get name return name. This is the getter method. It allows the classes to access the value of the name while keeping the variable encapsulated. Then we see the public abstract void open, public abstract void close. These are the abstract methods. They do not have a body which is any subclass that extends an app must provide their own implementation of these methods. This enforces the consistency across the all subclasses. And finally, we have the override, public string to string return name plus v plus version. This method overrides the default toString method. It returns a formatted string combining the app's name and version. Next, we have the message app. First, we have the class messaging app extend app. This means that the messaging app is a subclass of the abstract class app. It inherits the properties name and version, as well as the abstract method that it must implement. Next, private list string messages. This declares a list of messages. It will store all the message sent by the user. The keyword private means it can only access within this class. Now let's look at the constructor. Public messaging app, string name, string version, super name version, this dot name is equal to new array list. Here is what happened. Super name version calls the constructor of the parent class app to initialize the name and the version. This dot name is equal to new array list creates a new empty list to the store messages. Next, we implemented the abstract method, public void open. This method prints a message saying the messaging app is opened and loading conversations. Now the method. Public void send message, string recipient, string text. This method creates a formatted message. Adds to the message list. Prints confirmation that the message was sent. Next, public void read message. This method checks if there are no messages and it prints no message. Otherwise, it displays all messages in the inbox using a loop. Finally, the public void close. This method prints that the messaging app is closed. Now let's move on to the third class, the phone dialer app. First class phone dialer app extend app. Again, this class inherits from app, meaning it also uses the name and version and must be implement open and close. Next, private boolean on call. This variable tracks whether the user is currently in call. True means a call is active, false means no call is happening. Now, the constructor public phone dialer app, string name, string version, super name version that on call is equal to false. Super name version initialized inherited attributes. This that call is equal to false sets the initial state to not in a call. The next method, public void open, this simplify print that the phone dialer is open. Now the public void make call, string contact. This method sets on call to true. Simulates calling a contact, prints that the call is connected. Next, public void end call, string contact. This method checks if a call is active. If yes, it ends the call and sets on call back to false. Finally, the public void close. This prints that the phone dialer is closed. Now the music player app. Class music player app extend app. This means that the class inherits from the abstract class app, so it gets the name and version and must implement to the open and close methods. Next, the variables private string current song, private boolean is playing. Current song stores the title of the song currently selected. Is playing checks if the music is currently playing. Now the constructor, public music player app, string name, string version, super name version, this that's current song is equal to null, this that is playing false. Super name version calls the parent and constructor to initialize the name and version. Current song starts a null has no song yet. Is playing starts as false. Next, public void open. This prints that the music player is opened and loading the music library. Now, public void play song, string song title. This method sets the current song changes is playing to true. Displays the song being played. Next, public void pause song. Checks if the song is playing. If yes, it pauses the song and updates is playing to false. Next, public void next song, string song title prints a message about skipping. Calls play song to play the next track. And finally, public void close stops the music by setting it is playing to false. Prints that the music player is closed. Now let's move on to the browser app. First, class browser app extend app. Again, this class inherits from app. Next, variable private network module network. This shows association. The browser depends on the network module object to access the internet. Now the constructor, public browser app, string name, string version, network module network. Super name version, this dot network is equal to network. Calls the parent constructor, assign the network object so the browser can use connectivity features. Next, public void open that prints the browser is open. Now, public void browse URL, string URL. This method checks if the network is connected. If connected, it loads the URL and shows the connection type. If not, it displays an error message. Finally, the public void close prints that the browser is closed. And lastly, we have the camera app. First class camera app extend app. This class also extends to the class app. Next variable, private camera. This represents aggregation or association with a camera object. That the app uses the camera hardware. Now the constructor, public camera app, string name, string version, camera. Super name version, this that camera is equal to camera. Calls the parent constructor assign the camera object so the app can control it. Next, public void open that prints the camera app is open. Calls camera that activate to turn on the camera. Now, public void take photo string subject calls camera that capture photo to take a picture. Finally, public void close calls camera that deactivate to turn off the camera. Prints that the camera app is closed.
Dangal greetings everyone, I'm Devera and I'll be explaining the smartphone class, user class, and the main class. Starting with smartphone class. The code starts with public class smartphone. This creates a class called smartphone, which is like a blueprint for making a phone object. Everything inside this code defines what a smartphone can have and what it can do. The lines private string brand and private string model create private variables to store the phones like Samsung and model like Galaxy. These are private so they can only be accessed or changed through the class method. Private boolean is powered on is a true or false variable that tells us whether the phone is turned on or off. Next, the phone has different parts as object. Private battery stores the battery information. Private camera stores the camera. Private network network stores network info like Wi-Fi. Private storage stores the phone's storage. These are all objects, which means the smartphone is made up of other smaller objects. Then private list apps, installed apps, is a list to keep track of all the apps instead on the phone. Is all to keep track of all apps installed in the phone. Now, the constructor is public, smartphone strand brand strand model. This run automatically when we create a new phone inside this that brand equals brand. And this that model and model assign the phone's brand model. This is powered on equals false sets the phone to be off by default. Then the parts are created. This that battery equals new battery is 85 starts with 85% battery. This that camera equals new camera sets 108 MP camera. This that network equals new network module starts the new network module, and this that storage equals new storage gives 128 GB storage. Finally, this that installed app equals new array list makes an empty list of makes an empty list for apps. The method public void power on turns the power on. It checks if not is powered on. If the phone is off, it changes is powered on equals true and prints messages showing the phone is turning on, the battery level in the storage. If the phone is already on, it prints message saying it's already on. Similarly, public void power off turns the phone off. It checks if is powered on. If true, it sets is powered on is false and prints a shutdown message. If the phone is already off, it prints a warning. Public boolean is powered on simply returns whether the phone is on or off. This is useful for other methods to check the phone status. The method public void connect to Wi-Fi string SSID lets the phone connect to a Wi-Fi network. First, it checks if the phone is on using check power. If it's off, the method stops. If it's on, it prints a message showing the Wi-Fi name, connects using network.connect, and drain 1% battery with battery.drain 1. Public void installed app, install an app. It adds the app to installed apps, prints a message about stalling simulates using storage with storage.save file, and confirms that the app was installed. Public app find app string app name, search the installed app list for a matching app. It loops through the list, and if the name matches, ignoring case, it returns the app. If not found, it returns null. Public void open app string app name. Fits check if the phone is on, then it finds the app if the app exists. It prints a message, opens it with app.open, and drains 2% battery if not found. It prints the app isn't installed. Public void close app string app name. Finds the app and calls app.close if it exists. The gather methods like get network, get camera, get battery, get storage, and get installed apps allow other parts of the program to see the phone's components safely without changing them. Private Boolean check power is a helper method that makes sure that the phone is on before doing anything. If the phone is off, it prints warning and stops the action. It also warns if the battery is low. Finally, public void show status prints a summary of a phone's condition. It shows that the brand and model, power status, battery percentage, network, storage, and the number of installed apps. This lets the user see everything about the phone at a glance. Now the user class. The code starts with public class user. This creates a user class which represents a person who uses a smartphone. Everything in the class defines what a user can do with their phone. Inside, private string name declares a variable to store the user's name. This is private, so it can only be accessed through methods. Private smartphone phone declares a variable to store phone that belongs to the user. This shows has a relationship because a user has a smartphone. The constructor is public user string name smartphone phone. When we create a new user object, the constructor runs inside. This.name equals name assigns the user's name, and this.phone equals phone assigns the phone that the user will control. This links the user and the smartphone together. Public string getName return name is a getter method that returns the user's name when needed. Other classes can use this method to see the user's name without directly accessing the private variable. Public void turn on phone lets the user turn on the phone. First, it prints system out that print name plus turn on the phone to show what the user is doing. Then it calls phone.power on, which runs the smartphone power on method that we explained before. Public void turned off power. Public void turn off phone works the same way but turns the phone off. It prints a message saying the user is turning off the phone and call phone.power off. Public void connects Wi-Fi string SSD. Public void connect Wi-Fi string SSID allows the user to connect to Wi-Fi network. It prints a message. It first prints what the user is doing, including the Wi-Fi name. Then it calls phone.connect to Wi-Fi SSID to let the phone handle the actual connection and battery drain. Public void send message string app name string recipient string text simulates sending text. First, it prints that the user is opening a messaging app. Then it opens the app with phone.openapp app name. Next, it finds the app using app equals phone.findapp app name. The code then check if app instance of messaging app to make sure is actually messaging app. If it's true, it casts the app to messaging app and calls send message recipient text to send the message. Finally, it closes the app using phone.closeapp app name. This sequence makes sure only the correct app type is used for sending messages. Public void make call string app name string contact making a phone call. It prints that the user is calling someone. Then it opens the app and finish it. If app instance of phone dialer app and app as cast to phone dialer app and make call contact is called to start the call. After that, end call contact is called to end the call. Finally, the app is closed. Public void listen to music string app name string song 1 string song 2 allows the user to play music. It prints the action, opens the music app, and finds it. If the app is a music player app, it casts the app and call play song 1 to start the first song. Next song 2 to switch to the next song, and pause song 2 pause the music. Then it closes the app. Public void browse internet, string app name, string URL, simulates browsing online. It prints that the user is browsing, opens the browser app, and finds it if the app is browser app. It casts it and calls browser URL to load the website. Then it closes the app. Public void take photo, string app name, string subject, lets the user take pictures. It prints a message showing what the user is photographing, opens the camera app, and finds it if the camera is camera app. It casts and calls the take photo subject, then closes the app. Finally, public void check phone status lets the user see. It prints a message saying the user is checking the status and calls phone that shows status, which display information about battery storage, network and power state, and installed app. Class is the main class. The code begins with public class main. This declares a code main, which is the main class that runs the program. This class will contain main method, the menu system, and code that interacts with the user and smartphone classes and other classes. Inside static scanner, new scanner system in creates scanner object to read input from the user through a keyboard. The static keyword means this scanner belongs to the class itself, so all the methods inside can use it without creating a new scanner each time. Next, there's a method static int getChoice. This method is responsible for getting the user's input when choosing a menu option inside system out that print entered choice. Prints prompt asking the user to type number, then int choice equals -1 initializes a variable to store the choice starting with -1 as a default invalid value. The code try choice equals integer that parse int scanner that next line dot trim catch number format exception attempts to read the user input. Convert into an integer and remove any extra spaces if the user types something that is not a number. It catches the error and prints invalid input. Please enter a number. This ensures that the program does not crash with invalid input. Finally, the method returns the integer choice. The method static void print banner prints the program's title and school information. It uses several system .println lines to display border of equal signs, then the project title OOP. The method static void print menu prints the main menu. It displays a list of number options that the user can choose from. For example, 1 power on power off, number 2 connect to Wi-Fi, 3 send a message, up to 8 check the phone status, and 0 exit. This menu is displayed every time the user needs to choose an action. Next, the public static void main string args method. This is the entry point of the program where execution starts. The first line is print banner, which displays title header. Then the smartphone, my new smartphone Samsung Galaxy 25 creates a new smartphone object called my phone with the brand Samsung and the model Galaxy S25. This runs smartphone constructor we explained earlier. User equals new user Alex. My phone creates an object named Alex who owns the smartphone my phone. This links the user to the phone, so all the action and the user takes the effect this phone. Next, several apps are created. Messaging app, SMS, new messaging app, messaging 14 creates a messaging app called Messages with version 14. Phone dialer, new phone dialer, phone 12.1 creates the phone dialer app. Music player app, new music player app. Spotify 8.9 creates a music app. Browser equals new browser app, Chrome 120. My phone .get network creates a browser app that uses phone's network. Camera app, new camera app, camera 5.3. My phone get camera creates a camera app that uses the phone's camera. Then the program prints pre-installing apps to indicate that the apps are being added to the phone. Each app is installed using my phone.installed app. After installing all apps, it prints all apps installed and ready. And note to remind that the user to power on the phone before using any feature. Next, boolean running equals true creates a variable to control the program mains loop. The while running loop keeps the program running consistently until the user chooses to exit. Inside the main loop, the program uses switch statement to decide what to do based on a user's choice. For case 1, the program asks whether the user wants to power on or power off the phone. It prints the options 1 for power on and 2 for power off. then needs the user's choice. If the user selects 1, the program calls user the turn on phone to turn on the phone. And if the user selects 2, it calls user the turn off phone to turn off the phone. Case 2 allows the user to connect to Wi-Fi. The program prints a list of Wi-Fi network including home network, 5G, coffee shop Wi-Fi, and school LAN, and then connects to the chosen network using a user.connect Wi-Fi. Case 3 is for sending messages, and program first it prints a list of recipients, then asks the user to choose a message from a several option. After getting both the recipient and a message, it calls user.send message to send the message through the message app. Case 4 is for making phone calls. The program prints a list of contacts and reads the user selection, then calls user.makeCall to initiate and end the call using the phone app. Case 5 lets the user listen to music. The program asks the user to select first song and next song from a predefined list, then calls that user that listen to music to play the first song, switch to the next, and pause when needed. Case 6 allows browsing the internet. The program prints a of website including Google, YouTube, and Facebook, then calls user.browse internet to open the selected website in the Chrome app. Case 7 is for taking photos. The program prints list of subject such as sunset, lunch with friends, or a group selfie, and then calls user.takephoto using the camera app. Case 8 shows that the phone status by calling user.check phone status, displaying information like battery level, network storage, and installed app. Finally, case 0 exits the program. It prints a goodbye message and sets the running variable to false, which stops the loops and ends the simulation. Any input that is not between 0 or 8 is handled by the default case, which prints an error message reminding the user to enter a valid number. And that's all. Thank you.
Now let's move on to the output of our program. Before anything starts, the program automatically installs 5 apps and shows storage usage. Messages version 14.0, Phone version 12.1, Spotify version 8.9, Chrome version 120.0, Camera version 5.3. Each app takes 1 GB just like a real APK files. Storage is tracked in a variable so later actions can check remaining spaces. Here is the menu that has option 1 to 9. The power on and off, connect to Wi-Fi, send a message, make a phone call, listen to music, browse the internet, take a photo, check phone status, and the exit. Every time you return to the menu, the program loops using a while true loop. It only exits when you choose the option 0. Now let's go through every option one by one. Let's choose the option 1 to turn the phone on. Take note, nothing works until it's on. Let's enter 1 again to power on the phone. Now the phone is on and it prints this. Powering on, system booted successfully, battery is 85% and the storage is 123 GB free. The menu appears again and again because we keep testing the power option many times. This is just the loop in action. Now let's move on to the option 2. Let's choose the option 2. Here we have the 3 Wi-Fi networks to connect to. The home network, coffee shop, and the school LAN. Let's choose the number 1, the home network 5 GB. And as you can see, it prints this. Alex connects to Wi-Fi, home network 5G. Connecting to Wi-Fi, home network 5G. Connected to Wi-Fi and drained 1%. Level is now 84%. Now let's move on to the option 3. Let's choose the option 3 to send a message. As you can see, we have a 3 recipient, Mom, Juan, and Professor Santos. Let's select recipient 1 for Mom. Then select the option 1, good morning, and I'm heading to school. And as you can see, it prints this. Alex open messaging to send a message. Opening messages, messaging app opened, loading conversations. It drained 2%, level is now 82%. Now, message sent to Mom, good morning, I'm heading to school. And message app closed. Now let's move on to the option 4. Let's choose the option 4 to make a phone call. Still, we have 3 people that shows earlier in the messages. Select contact 2 for Juan. And as you can see, it prints this. It repeats many times in the output because we kept testing battery drain. So, Alex make a phone call to Juan, opening phone dialer opened, drain to 2%, level is now 80%. Calling Juan, ringing, call connected with Juan, call with Juan ended, then the phone dialer closed. And now let's move on to the option 5. Let's choose the option 5 to listen to the music. Select first song 1 Espresso by Sabrina Carpenter. Select next song 1 Die with a Smile by Lady Gaga. And as you can see, it prints this. Opening Spotify, music player opened, loading library. It drained 2%, now the level is 78%. Now playing Espresso by Sabrina Carpenter. Skipping to the next track, now playing Die with a Smile by Lady Gaga. Then it paused, Die with a Smile, Lady Gaga, then music player closed. Now let's move on to the option 6. Let's choose the option 6 to browse in the internet. As you can see, we have 3 websites that is available. Google, YouTube, and Facebook. Let's select the option 1, the Google. And as you can see, it prints this. The Alex browses the internet, opening Chrome, browser opened, drained 2%, level is now 76%. Loading the Google from via Wi-Fi, browser closed. And now let's move on to the option 7. Let's choose the option 7 to take a photo. And we have option 3 here to take a picture. The option 1 is to the sunset overtime over the campus, lunch with friends, and group selfie. Let's select the option 3, the group selfie. And as you can see, print this. Alex takes a photo of group selfie. Opening camera, camera app open, camera activated 108 MP, drained by 2% and the level is now 74%. Photo captured group selfie at 108 MP. The camera is deactivated and the camera app is closed. And now let's move on to the option 8. Let's choose the option 8 to check the phone status. And as you can see, it prints this. Alex checked phone status. Device Samsung Galaxy S25. The power is on. Battery 74%. Network Wi-Fi. Home network 5 gig. Storage is 123 GB free. And app installed is 5. Now let's go back to the option 1 to turn off the phone. Choose the 1, then choose 2 to power off. And as you can see, it prints this. Alex turned off the phone, shutting down, then it says goodbye. Finally, the option 0 to exit the program. And as you can see, it exit simulation and it says goodbye. That is the complete flow of our program and explained every option. Battery keep draining to 1 to 2% with every action, just like a real phone. The many repetition you saw were just us testing the same options over and over to watch the battery go down. We started with the app installation powered on the Samsung Galaxy S25, connected to Wi-Fi, used every features, the messages, calls, music, browsing, camera, and the status check. And finally powered off and exited cleanly. And that's all, thank you.
I just had to let you know you're